Question 6. Draw a diagram to show how 1.5 volt cells should be connected together to give a potential difference of 4.5 volts. So if this is a 1.5 volt cell, we will connect the other two cells in series with it. So that's 1.5, 1.5, 1.5. The overall voltage there will be 4.5 volts. So we connect them end to end so that the voltages add up and an overall voltage of 4.5 volts is produced. So student built a circuit shown below. Here, the battery voltage is 12 volts. The current leaving the circuit is 1.6 amps. That current will go through P, it will go through Q, and 1.6 amps will return back to the battery. So calculate the total resistance of the circuit in the diagram above. So one way to calculate the total resistance is to add the resistance of P and the resistance of Q, and that will give you the overall resistance. However, in this question, we have not been given the resistance of Q, so we can't go down that route. The alternative route is if we knew the total voltage and the current going through the battery, we could find the total resistance, and that is the total voltage over the current through the battery, which is 12 divided by 1.6 amps, and we get 7.5 ohms as the total resistance. Part C is the resistance of P is 3.5 as shown in the circuit diagram. Calculate the resistance of Q. Now, what we've just done is we found the total resistance is 7.5. So the resistance of this plus the resistance of this is equal to 7.5. So 3.5 plus something gives me 7.5, and that is 3.5 plus something gives me 7.5, and that is 4 ohms. Part D. The student connects two resistors in the diagram above in parallel. So rather than in series side to side, what we do is connect them in parallel. And what happens to the total resistance? So when we connect resistors in parallel, the overall resistance, the total resistance in the circuit decreases. Okay, so the overall resistance in the circuit decreases. So adding resistors in parallel into a parallel circuit reduces the overall resistance in the circuit. Okay. Question 7. The image shows a battery-powered drone, and you have to complete the sentence. Choose the answers from the box. So one of these words goes into each line. So as the drone accelerates upwards, that means speeds up in the upwards direction. What happens? The kinetic energy increases. And because it's moving upwards, gravitational energy also increases. So accelerates means speeding up. That means kinetic energy goes up. And moving upwards, we know gravitational energy increases the higher and higher we move from the surface above. So higher vertically, the GP increases. And what decreases? The energy store of the battery, that's a chemical store. And so the chemical energy store of the battery decreases. Part B, in the USA, drones are not allowed to be flown too high above the ground. One risk is risk of collisions with aircraft, or you could have written if the drone loses power, it falls out of the sky and it could hit something or someone on the ground and cause damage. Now, this is one possible risk. This should actually be a 1-mark question, but if you've mentioned something very similar to this, I've given you both marks. Part C, calculation is required. We need to work out the maximum energy stored inside the battery when the drone can be flown. for 25 minutes before the batteries need recharging, and the power is 65 watts. So the power of the battery is 65 watts. So we know a formula that connects energy, power, and time, which is energy transferred equals power multiplied by time. The power is in the correct unit of watts, so that's 65. Time is in the incorrect units of minutes. We need to convert it into seconds. So 25 multiplied by 60 gives us the correct unit of seconds. So 25 minutes, 60 seconds in every minute. And we'll do 25 times 60 to get the time in seconds, times about 65 watts, and we get the energy of 97,500 joules. Question 8. A student investigating insulating properties of a newspaper. Figure 1 shows the apparatus the student used. So you've got digital thermometer in some hot water, and we've got layers of newspaper wrapped around the metal can to reduce the amount of heat escaping. So what we are trying to do in this experiment is to investigate insulating properties. And as we can see, we've got a temperature decrease on the vertical axis and the number of layers. So when we have no layers of newspaper, the temperature dropped by 18 degrees. When we had 7 layers, we had a drop of 14 degrees. 16 layers, we had a drop of about 11 degrees. We had 24 layers, we had a drop of 5 degrees, and at 32 layers, we had a drop of 8 degrees. Okay, so we can see as the number of layers gets higher, the temperature drops less and less. So we need to describe a method of how we get these results. Okay, how do we get temperature decrease? And how do we get the number of layers? So we just get a different number of newspapers. So start off, we're going to use several layers of newspaper. We could say from 0 all the way to 35 layers. Beginning, we had no newspaper for our first result. So wrap no newspaper initially, and then add 1 newspaper layer each time a set of results are taken, or maybe 5 layers at a time. It's up to you. We pour in the hot water into the metal can. Okay, we record the same initial temperature each time for each set of layers. So for 0 layers, we start at the same temperature. For 5 layers, start at the same temperature. 10 layers of newspaper start at the same temperature. Okay, that could be our control variable. And then as soon as the temperature that we have is the same, we start the timer, and after, let's say, 5 minutes, record the final temperature. And we can find the temperature change or the temperature decrease. We knew the starting temperature. We know the final temperature after 5 minutes, so we can work out the temperature decrease by taking the 2 away. And that is our dependent variable, the temperature decrease. And we have shown how we can find that. The next, you can then look at another 5 layers, so add 5 layers on and repeat the experiment and find the temperature decrease. And you could repeat the same experiment for each type of layer. So repeat the experiment with the same number of layers and find an average, and that reduces random error, and it could identify anomalous results as well. Okay, so I have put 1, 2, 3, 4, 5, 6, 7, and different possibilities that you could pick up marks for. Part B, the student could have used a data logger with the temperature probe instead of using a digital thermometer. Figure 3 shows the reading on the digital thermometer and the data logger. Now they are both the same precision, they both do the same number of decimal places, so one is not more precise compared to the other, but the data logger records readings every 10 seconds, whereas the digital thermometer, you decide on when you want to make the recording of the reading. Now, explain why it is not necessary to use a temperature probe and a data logger for this investigation. The reason is we don't need to use a data logger because to find the temperature decrease, this temperature decrease after 5 minutes, all we need to know is the starting temperature and the ending temperature. And that's what will allow us to find the temperature decrease. We don't need to know the in-between temperatures. Okay, so this experiment, the temperature decrease over 5 minutes is calculated. Initial and final temperature are required to find the temperature decrease, not any readings in between, therefore not necessary to use the temperature probe over the data logger. We don't need readings every 10 seconds because we're looking at the reading at 5 minutes and at 0 seconds, and those are the two readings we need. Question 9. We've got a person going down on a zip wire. Okay, so a person starting off at a certain height and moving down through a zip wire. The person loses 1.47 kilojoules of gravitational potential energy. The mass of the person is 60 kilograms. The strength of gravity on the Earth is 9.8 Newton per kilogram. And the question asked is calculate the vertical change in height from the starting position to the ending position. And to do that, we need to use the GPE formula. Gravitational potential energy is equal to mass times gravitational field strength times by the change in height. In the question, we want to work out the change in vertical height. So I've rearranged the formula to get H equals, which is GPE over mass times gravitational field strength. The GPE is given in kilojoules, not in joules, so we need to convert that. 1.47 times by 1,000 to get from kilojoules to joules, and that's 1,470 divided by 60 kilograms, that's the correct unit, and 9.8 is the correct unit as well of newtons per kilogram, and we get a height, vertical height of 2.5 meters. Part B, as a person moves down the zip wire, her increase in kinetic energy is less than her decrease in gravitational potential energy. You've got to read that a couple of times before you kind of make sense of it. But in other words, it says that the loss in GPE is greater than the gain in kinetic energy. So not all of the GPE that is lost goes into kinetic energy. That's what this statement corresponds to. So not all of the GPE that is lost on moving vertically downwards is not going to kinetic energy. So where is it going? That's the question. So some has probably gone down as friction between the cables, and some has gone down as air resistance between you as you're falling through the air, and some energy has gone through that as well. So work is done against friction and air resistance. So energy is transferred through friction and air resistance, and that eventually transfers as heat, so thermal energy into the surroundings. Okay, so that's where the energy has gone. So it's to do with the friction and air resistance. So energy is transferred into heat into the surroundings. And part C, different people have different speeds at the end of the zip wire. explain why. So we're going to build on what we said before. So people come in all shapes and sizes. This means they all have different surface areas. So as they increase their speed, as they are moving down, so they are moving and falling, getting faster and faster, and a bigger person with a bigger surface area will have and experience a large air resistance, therefore will have a more of a resistive force. So the net downward force is going to be lower. So the net downward force is going to be lower, and that means that the person will accelerate less and will have lower speeds if they have a large surface area. So that's why people can have different speeds at the bottom of the zip wire.